Okay, so if you're off by a penny or something, that's okay. Are you off by more than a penny?
More than a penny.
Or are you off by like more than $1? Do you have a 6 here?
No, no, I have a 6 there, I'm off.
Okay,
Oh, wait.
so it depends on if you round, like if you round things. Yes?
That's what I was trying to figure out, is why that I'm off by 3,000.
Oh, no. This is your answer, right? This is how much money would be in the account after 7 years.
Right.
But look at the question. The question says how much interest was earned.
Oh, okay.
Okay?
I forgot about the interest.
How much interest was earned. So what we're saying is if you start with 3,000 and 7 years later you have that much, how much did you gain?
So you gained the 500.
You gain the 500. If you take that and subtract that, you get this number. Right? Your money grew, right? You have more money than you started with. How much did it grow by? $536.41. That's the interest you've earned. Now, if this were a credit card, then that would be how much more you have to pay back, right? You bought a TV, it was $3,000, but you're going to wind up paying $3,536. So you're basically having to pay a fee to borrow that money. Any other questions on that? No? All right, we move on. Solve, number 6. We're cranking, aren't we? Number 6. We want to solve 4 to the 3x equals 8. All right, I'm asking you to solve for x. Where's x? Up in the exponent. How do we get x's down from the exponent? You got to bring it out front, but you can't bring it in front unless you have a natural log on both sides, right? Or, well, you need a natural log in front of it. So I'm going to take the natural log on both sides of this. I'm allowed to do that now because this 4 to the 3x is by itself. On number 7, it's not by itself, so we do something a little different. But here, we can just bring the natural log in on both sides. That allows me to take the entire 3x, drop it out front. That 3x is in front of this natural log of 4, equals natural log 8. Now, in other problems, we saw that when this is natural log of e, it turns into a 1, right? But see, that's not an e, so we unfortunately have to just deal with that. Here's what I'm going to do. I'm going to divide both sides by natural log 4. It'll go away here. I'll be left with 3x equals, now on my calculator, I'm going to do the natural log of 8 divided by the natural log of 4. I'm going to type it all in at one time and get an answer. Please verify that, well, check that you get the same answer, because I don't want you to come in on the day of the test and be like, oh, I never knew how to do that. Let's see. Oh, it's just 1.5. Yeah, it's just 1.5. And then what's the next step? Divide by 3. Right now you can just divide this 3 out. And you get an answer for x. X is a half, 0.5. There we go, we're done. Yeah? You like that one? I just give you like 20 of those and call it a test? Yeah. All right. Let's do number 7. Just give you one of those, right? Just one of those. Give you just that problem, right? Don't even change it. How about just that problem? You know how we were talking about mortgages a while back? Yes. So I'm going to mute this real quick. Let's continue. All right, so what are we doing here? Solving for x, right? Where's x? Up here in the exponent, right? And we're trying to solve for it, so we need to bring it down, but there's a whole bunch of other crap that's in the way, right? So our goal is to get the e that's raised to that power, to get it by itself, right? So we're going to do this kind of like an equation back in the very beginning, a linear equation. Subtract 7 first on both sides, right? Subtract 7. Gone. We get 3e to the x minus 1 equals, that's 14, right? Okay, it's almost by itself. Not yet, though, right? We have a 3 that's being multiplied in front of it. So to get rid of that multiplication, we have to divide both sides by 3. So divide by 3, divide by 3. You get e to the x minus 1 equals, okay, that's going to be 4.6. 6, 6, 6, 6, 6. There it is. Does Goofy do that? Huh? I'm sorry, nothing. All right. So, what now? Okay, okay. Okay. All right. What now? What now? We're trying to get that x down, right? We can bring the log in at this point, right? So we bring in the natural log. Both sides, right? Both sides. Great things happen on the left, right? Because when we drop this down in front, this time the natural log of e turns into 1. That's just one of the properties of logs that we talked about, right? So I have the x minus 1. Let me go ahead and just write it this one time. Right side, I'll have to do that on my calculator. And you don't have to, just do like 4.66 if you want on the calculator. It's no big deal. This turns into a 1. So we get x minus 1 equals 1.54. Yeah? Y'all get something like that? Final step. Add 1. Add 1, gone. X equals 2.54. There we go. X equals 2.54. Any questions? It's always easier watching me do it, right? It's a little different when you sit down at a test. But, that's the thing. You just want to try and relax and feel confident. I've always felt like if you come in defeated, then that's exactly what's going to happen, right? But if you have a little bit of confidence in yourself, believe that you can get it done, helps out. All right, number 8. Wow, we're going to have time to spare, possibly. Number 8. I think if there's time to spare, what I'll do is I'll put up 10 new problems that you can go home and practice 10 new problems, okay? All right, so number 8. What interest rate is needed to double your money after 5 years? That's it. That's all I give you. So we had a discussion in class about when you're trying to double or triple your money, or it doesn't matter what you're trying, double, triple, quadruple, that the amount of money doesn't matter, right? So what we're asking here is what interest rate is needed to double your money in 5 years? So what that tells me is that using this formula, I want the amount at the end to be twice as much as this, right? Doubling my money. So what I can do is I can put 2p. That's what the amount is I want at the end. The original amount that I start with is p. E to the RT, and I know I'm doing this for 5 years, so I'm going to put 5 times R. So I replaced the t with 5, which gave me 5R. And then the 2p came from the fact that I'm doubling my money. If it were triple, I'd put 3p. If it were quadruple, I'd put 4p, right? Now, what you can do, and this is the beauty of the problem, is that you can divide both sides by p. And if you do that, you get 2 equals e to the 5r. And now this is just like the problems we were doing a second ago, right? You're trying to solve for r. Let's bring it down. To bring it down, we need natural log on both sides. So natural log 2 equals natural log of e to the 5r. That means natural log of 2 equals, we'll take the 5r, drop it in front. but the natural log of e will turn into a 1. That's a 1. Believe it or not, that's a 1. So let me get on my calculator. I'm doing natural log of 2. Point 693 equals 5r. So 0.1386 equals r. How did I get that? Just divided by 5, right? Both sides? Okay, that is a correct answer. I'll give you full credit for that. But remember, it's an interest rate, right? So another way we could have written that would be 13.86%, which is extremely high interest rate. If you want to double your money in 5 years, then you're going to have a very high interest rate for that to happen. All right, good. All right, number 9. Number 9 already? Okay. How much time is needed to turn $5,000 into $7,000 at an interest rate of 17.99%? So for number 9, we're trying to turn $5,000 into $7,000 at an interest rate of 17.99%. And the question is, how long does it take for that to happen? So this is more like a credit card problem. It's like you spent $5,000 and the interest rate on the credit card is 17.99%. How long is it going to take for that $5,000 to grow to $7,000 if you're not making any payments? So I'm going to use that the same shampoo formula, right? Except the A is what, the P is what, the E is what, the R is what, the T is what. So A 7,000, P is 5,000 is what we start with, which will convert to a percent, right? Or from a percent to a decimal, and then T is what we're solving for. So how much time does it take at this interest rate to turn that money into that, right? All right, so it's very similar to this problem, except it's not P's. It's the same idea, though. We're trying to solve for one of the variables up here. So I'll start by dividing both sides by 5,000. Right, so you do 7,000 divided by 5,000, you get 1.4 e to the 0.1799t. I'm going to continue over here. What now? Natural log. So natural log of 1.4 equals, okay, on the right-hand side, the 0.1799t comes down, but then I have natural log of e next to it. And that natural log of e is going to turn into a 1, right? Let's see here. I don't think Goofy can do that. All right, 1, right? All right, natural log of 1.4. I'm just going to keep going on about that. I'm sorry. I'm just going to keep messing with you. 0.3364. Let's just round that to 5 equals 0.1799t, right? So I took the natural log of 1.4 on my calculator, and then the natural log of e went to 1 again. And now it's kind of weird, but I'm going to divide, right, 0.3365. I'm going to divide that by 0.1799. I get 1.87. You got that? So what is that answer? 1.87 what? Years. So it takes a little under 2 years to go from a debt of $5,000 to $7,000 if you got this credit card at 17.99%. How are you feeling about this? It is 11:47, so we've taken 47 minutes to do 9 problems out of the test, right? We have 1 more to go. And the 10th one is the one that has to do with what we talked about at the end of class last time. Oh, and I don't think I uploaded the video for last time, did I? No. Okay, so here's what happened. Thursday, I don't know how y'all did with the storm, but we did pretty bad with the storm at our house. I had water dripping in my master bedroom out of the ceiling, and then our fence, our neighbor's shed got flipped over and landed on our fence, and we had hail too. Yeah. So I mean, it was a mess.
During that day, I was working over at SeaWorld, and I work right next to the dolphins, like
Yeah.
the open area dolphins.
Uh-huh.
We move them during the storm.
Oh,
They were
yeah.
just getting hit by hail.
Really? It was crazy. That storm was crazy. Yeah. Yeah, we lost power from 6. It came in at 6 p.m. about. It was about 6, and we lost power till 7 or 8 a.m. the next day. Yeah, it was. And then no internet. Like, what do you do, right? What do you do? Even my cell phone internet wasn't working. Yeah, it was weird. Yeah. Okay, so anyways, the whole point is that I rushed out of here on Thursday because they closed campus, and it's like pushed us out. I forgot to take my camera that has the SD card in it, so I couldn't upload anything over the weekend. So I just got back to my office this morning, and I will look at getting things uploaded later. I'll probably wait till this evening because my internet at home is much faster than the one here, so I can upload things in about 10 minutes as opposed to like 2 hours here. So hang tight, it'll be there. All right, last problem, here we go. All right, so half-life. So I gave you a formula. It said this, A equals A naught E to the KT. This was the formula, right? And we said that looks almost exactly like the shampoo formula, except that the things kind of represent different things. This is the amount that you're starting with. This is the amount that you end with, but the amount could be anything. It doesn't have to be money, right? It could be the percentage of alcohol in your system or something like that, right? Or we talked about some other things, right? Carbon-14. K is called our growth or decay constant, and then T is time, and time can be measured in anything in this formula. So here I say, all right, the half-life of alcohol is 5 hours. First, we want to find the equation for the amount of alcohol present after T hours. Then I ask you how much alcohol is present after 24 hours, and then how long does it take to have 20% of the alcohol in your system. So the idea here is that if you consume an alcoholic beverage, we're going to say you now have 100% of that alcoholic beverage in your system. We're not saying that your blood alcohol level is 100%. You'd be dead, right? So when we're talking about 100% here, we're talking about the quantity of what you ingested, not blood alcohol levels, all right? So half-life being 5 hours means this. This will work no matter what this number is and whatever this unit is. This could be 5 days. This could be 25 million years. Doesn't matter. Here's what your next line will be. This becomes a half because that's half of it's going to go away. This number becomes 1. This is E to the what? K. What goes in for T? 5. What this formula is saying, what this line is saying, I should say, is that after 5 hours, you've gone from 100% of the alcohol you consumed to 50% or half, all right? So this is the only thing I'm going to give you in the problem is the half-life of something. And then from that, you have to do this, solve this for K, and then once you do that, you'll have a generic formula. So this is a 2-step process. You first find K, then you have the generic formula, and then you answer parts B and C. So let's get K here. This is 0.5, 1/2. 1 in front of this doesn't matter. I'm going to write that as 5K, not as K times 5. We're beating this horse to death. I've never understood that saying.
thought it was beating a dead horse.
Oh, beating a dead horse. I'm sorry.
Not beating a horse to death.
Sorry, same thing.
Goofy just got really dark.
Yeah.
That's I'm trying to prove I'm not goofy up here. Look, so let's finish this. Yeah, you don't know what I'm doing? Trying to drop this down. I need a log on both sides. Bring in the log. Left side drops down. 5K. Natural log E. Natural log E is 1. Beating a dead horse. Beating a horse to death. All right, so on the left, hey, are you getting a negative number on the left? I am. Yeah. All right, that's okay. 0.693, let's just go 3 decimal places equals 5K. And now divide both sides by 5. Negative 0.1386-ish is K. So I had told you last class that K up there is called either the growth constant or the decay constant. It's a growth constant if it's positive and it's decay if it's negative. So this is actually a decay, which makes sense because the alcohol, as time goes on, the alcohol goes away, right? You don't get more drunk by not drinking, you know, you drink one beer and just keep getting more drunk. That doesn't happen, right? So, all right, so now the formula, right? This is going to answer part A. Part A is A equals A naught, which we can replace the A naught with 1 because you're always going to start with 100%, right? Does that make sense to you all? So let's replace that with 1. And then e to the negative 0.1386 t. That is our master formula right there. So you first go and find K with the half-life, right? Then you have your master formula, and now we can answer part B. Part B says, how much alcohol is present after 24 hours? So I'm giving you the time, right? 24 hours. And the half-life was measured in hours as well, right? So all I'm going to do is take this formula and replace the time with 24 and then use my calculator, all right? So the amount present will be, I'll just put E, you don't need the 1, negative 0.1386, put a 24 next to that, multiply. You could probably type all of this into your calculator at one time. See, we don't need natural log here, right? There's no natural log button used for this part B. Where does that saying beating a dead horse come from? I don't know. That's weird. You never heard that?
I think it had to do with the horse tracks. Was like they're trying to force the horses to like race for longer, I guess. But like the longer they go, they can't run.
I'm going to look it up. I'm curious. My daughter asked me about that the other day. She was like, where did that saying come from? I'm like, I have no idea.
Like once a horse like leg breaks, it can't like run anymore. So it's kind of like, I don't know.
Yeah, they usually put a horse down if it breaks its leg, because then it can't like just even walk around. All right, so that's our answer. Yes?
It says that it wasn't, the horse isn't even supposed to be like an actual animal. It was just slang for like work that was charged on a bill that but not carried out yet.
Interesting. It's weird, all these sayings that have like don't make we say like we use them. Well, obviously some people don't use them because you haven't heard of it. But certain sayings that when you think about it, you're like, why do we say that? That doesn't. Okay, but wait, what is it? What is our answer here? After 24 hours, how much alcohol is present? How much alcohol is present? This, right? But remember, 1 was 100%, wasn't it? So this is actually a percent. We need to convert this to a percentage to get what percent of alcohol is left. So what? 3.59%? 3.59% of the alcohol. Yes? You didn't get that answer? Did anyone get that answer?
I did.
Yes? Can I come see how you typed it in? Excuse me. Yeah. Put the 24 in parentheses with the other. Like, yeah, like don't close your parenthesis there. Yeah, try that and see what happens. Yeah, no. Because you put the parenthesis there, your calculator is doing all of this and then multiplying that answer times 24. So you need to just start over. Start over. Do E, and now negative. Yeah. Oh, I see. Your calculator's tricky. So here's what you're going to have to do. You're going to have to do this on your calculator first. 1386. Do that times 24 on your calculator first. Know what I'm saying? Do that first. Times 24. Okay. Okay, that gives you what? Negative 3.3264. Now raise e to that power. So you'll have to write that number down. Now do e raised to that power, and it should come out.
I saw it last class, yeah.
Okay. All right. All right.
Like, he could be like your brother. Like, if you had a beard, he look exactly like you.
Yeah.
He's from The Walking Dead.
Yeah.
Yeah.
I've heard that more recently than I think we said that in class the other day, right? Yeah.
Nicolas Cage.
And I sound like Nicolas Cage, and I look like Goofy, and the Walking Dead at the same time. All right. Hey, did we finish? Oh no, we didn't. All right. What time is it? Yeah. We need to do C. Let's answer C. So for part C, how long does it take to have 20% alcohol? So this time, I'm not giving you the time, right? I'm giving you how much is there at the end. 20% using that master formula that I just erased. Here was our master formula. Right, that was our master formula. What we're saying is that we want the amount at the end to be 20%, which is 0.2, right? Because 1 is 100%. So don't put 20 over here, put 0.20. 0.2, you don't need the 0. 0.2 equals, you don't need the 1. E to negative 0.1386 t. And now you're trying to solve for t instead of just plugging it into your calculator, so we'll have to do the log on both sides. Any questions on why I'm doing that? No. We're good? Yes?
Is it okay if I pass out that before?
And just do that? That's fine. I just keep doing it over and over just so that people see it's actually dropping out in front, but you get to a point where you're like, yeah, no, they just go away, right? So calculator, I'm going to do natural log of 0.2, not 2, right? Natural log of 0.2. Almost done. Negative 1.609 equals negative 0.1386 t. Divide. Two negatives, right? 7.71 hours, right? Not days, hours. How do I know it's hours and not days or years? The half-life was, what was the half-life of alcohol? 5 hours, right? So everything here is in hours. All right, what do y'all think? Wednesday, think you'll be ready? Okay, I said I would put up some more problems. Yes?
We're going to have a final.
We're going to have a final? Yes. So we actually only have, Not counting today, we're only going to meet 3 more times before the finals. So we meet on Wednesday, we have our test, and then next week is our last week of classes. And then the following week is finals.
Wait, what?
Yeah, that right? Look at the calendar.
Finals on the 10th, right? That's May 10th.
I believe so, yeah. Let me look at the calendar. Pardon me? Some classes are doing their finals next week? What classes?
Like my kinesiology class is doing it. My
Oh, okay. Yeah, certain classes might do it during the last week. It depends because there's pretty strict rules about, like if it's a normal 16-week class like this is, that we have to do a final exam. We can't just be like, hey, last day of class, we're going to take a test, and then no one has to come on finals. Like we get in trouble for that sort of thing. But for something like that, I don't know, maybe it's different. Let me see. We have, yeah, that's right. So we have this week, the following week, and then our finals.
Is there going to be a review for the finals?
Oh yeah, I'll give you a review. Yeah, there will be something, but it'll be next week, right? So, we good? Understand? All right, so I'm gonna put some problems up here. And otherwise, you're free to go. If you want to hang back, you can have some more problems to do here. Yeah.
Okay. So I divided those two, and I got some wonky ass number here. What did I do wrong?
Let me see you type it in again. Are you using the negative key or the minus key? Because there's
Using the negative.
okay. So go negative.
So let me do that again.
Yeah.
Negative 1.609 divided by
Negative again.
negative point
Point.
1386.
What the hell?
Yeah.
Hold on a second. Do natural log of 0.2 again. Let me see. I have it in my history here. Oh, hey, hold on. There's a mistake. Yes. There. No, why didn't anyone else bring that up? Oh, wait. No. You did natural log? No.
Yeah. I did natural log.
Hold on.
0.2.
On that last problem we just did who else got 7.71? You got 11?
No one else said it?
Oh, I see what. I have 2 numbers flipped. That's what it is. I put 069 instead of 609.
So it should be.
It's 11, yeah. Please go back and change that. That's my mistake. On number C. On part C,